Yo guys, what's up? Today is gonna be a stream of 4 hours, and I will be doing cold calling today. So no need to worry about that. And let's just start with the starting, and let's don't waste time. By the way, I'll be back in 1 minute. Give me a sec, and I will be back. Okay. So yeah. Mm, wait. But guys. Here. Okay. So I don't know, guys. You guys can hear me. I think that you can guys hear me. So yeah. Mm, so let's get started with the starting and a lot of reading today. So here's the book I was talking about earlier. Yeah, talking is this month's book. This month of copy for exam. It's gonna be so exam gonna be like this. Okay, so per day there's gonna be two subject exam. Okay, per day is gonna be two subject exam, and days is for like 3 days, and for 3 days it's gonna be six subjects. So for upcoming Sunday it's gonna be physics and English. Monday is gonna be chemistry and no, not chemistry, bio and maths. And in Wednesday it's gonna be English and no English, chemistry and Nepali. English and chemistry and Nepali. So let's don't waste time and let's get started. Okay, let's start studying. So is the book I was talking about. Is the theory, is the numerical, and yeah. This is all on site, and I will not look at the computer right now because I will be taking break in every like 5 to 10 minutes. 5 to 10 minutes, for 30 to 35 minutes of break, and yep, I will be seeing if you guys any see like drop a comment or something like that. So yeah, can be like that. Mm, so bye. Hope you guys can see me. I'm over here. I hope you guys can see me. Okay. I don't know if you guys can hear me or not. So right now I will not be studying English for right now. I'm gonna study the theory first of all this theory, and I got something. Okay, okay. First of all, let's see how many for what subject I need to learn up to this, and for what subject I need to learn from up to this. Okay, so first of all, let's do that, and then after we will start studying. First of all, let's start with heat and temperature. And heat and temperature, what have sir shown us for today? So what sir has shown us for today is, let's see. Mm, okay. So I was talking about, yes. Not this. This one of which this one. Mm, 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 Wait, guys. I think this one. Yeah. This one is of chemistry. This one of chemistry, and this is this one of, yeah. This is what I'm talking about right now. Mm. Mechanics, physical quantities, scalar quantity, heat and temperature, temperature and thermal expansion, heat and strength, and thermal strength, tension due to the change in gravity. This means that the change on that we can do, and the electrostats, electrical charge, Coulomb's law, and Coulomb force completed. Okay, physics and physical quantities, chemistry. Let's start with heat and temperature. The temperature and thermal expansion, heat and stress and strain, thermal stress, and then after we'll move on into next one. So we'll be then after we'll be working up to the next one. Okay. Yeah, this is all I want to show. We will not watching the screen for right now. If you're gonna guys say something in the middle, can just drop a chat, and I will saw it. And then after I will be starting, and I noticed something that it's gonna be getting it is getting darker outside. So yeah, and I'm assuming that I'm getting a lot of kicks today because I have used I think I have used a lot of what I can say a lot of a lot of hashtags and a lot of tags. So I think it will be reaching to more people. So yeah, let's don't waste time. Okay, I know it's getting dark outside, but yeah, this is how it is. Mm, mm, this is how it is. So yeah, for today you guys can manage. I got my copy over here. So the thing I wanna say is what the first of all, we're gonna study the temperature and thermal expansion, heat and temperature. The basics we need to learn first of all, just to revise and just know things that I have studied, and then after I'll go straight up to temperature and thermal expansion. Thermal expansion to strain and stress. Okay, thermal strength and stress. Okay, okay, okay. Yep, we have it. Thermal expansion. Expansion. All the numericals we are talking about, and by the way, this is only the one chapter, which is like one third of math. So I will study the heat temperature, electrical stats, and mechanics too. So don't worry about that. So yeah, I think I'm assuming right now it's getting too dark outside. I didn't notice that at first, but it's getting fast dark outside. So yeah, it's gonna be like 4 hours of streaming. We already hit 10 minutes up to round. Even not starting a bit. Yeah, I will be doing yes, and I will be doing the numericals too in this video. So in this stream, sorry, in this stream. Wait. Let me guys see. Okay, wait, monsters again. So wait, guys, wait, guys, wait. Sorry for that. I didn't know that you can guys not hear see me. So yep, I will be not seeing for you right now. I'm gonna study for like 30 to 45 minutes straight, and you guys gonna listen me and how I study. According to calorie theory, according to this theory, heat is invisible, weightless, and odorless fluid, which is called calorie. Dynamic and molecular theory. According to the theory, heat is the total sum of kinetic energy possessed by a molecule by means of transition and vibrational and rotational motion. So, in dynamic and molecular theory, the heat is also stated as the total sum of kinetic energy present in a molecule in the form or in the means or in the form of rotational, translational, and vibrational motion. Let's see more about heat. V is equals to Ek plus Ep. The sum of all the types of energy is called internal energy. The total energy by means of any motion is called thermal energy. Non-mechanical transfer of heat thermal energy is due to the temperature difference called in a heat energy. Heat is the transfer of thermal energy. Absolute content of heat cannot be measured. Heat is heat of a body or heat of a body or temperature in a body is meaningless. All device used in a measure heat is called to measure heat is called calorimeter. It is derived unit. It is yes, its SI unit is SI is joule. It is CGS unit is calorie. CGS unit is calorie means 1 cal is equal to 4.2 joules. And most important thing is that when you in 11th grade or in any way, studying before an exam, like a day before exam, is not gonna work for you, especially because there is 2 month content before. I'm just giving a pre-term. It's not like a full-fledged free like term of my and it's already too much for me because my physics subject is divided into three groups, which is like heat, mechanics, and electrical charge. Okay, so these three subject, like division I need to learn, and then after my physics like will be completed. Okay, and then after I will go to English. I gotta study English too. And the most hard part of physics is that not only theory is important but also the numerical. And the bad part is that all three division contains numericals, and I gotta study all of them and practice all of them. By the way, I have got the physical. I got the numerical book, so not to worry about. And I got the numerical physics numerical workbook, so I will be practicing from here too, and not to worry about from here. Yep. Um, that's all I want to say. Yeah, let's get started. Let's finish the theory part and let me know that if this way of learning is very like effective. I don't know. I think it's not effective because starting before a day before exam is not effective for sure. It is the so let's get started. So let's start. Let's start. Okay. Temperature. It is the effect of heat. It is the measure of average kinetic energy per molecule. It is fundamental or an intrinsic property. It is a basic property. The property which determines the direction of flow of heat is called temperature. It is the property which decides whether the systems are in equilibrium or not. A device used to measure temperature is called thermometer. C degree, F degree, K degree, and Rn are the different temperature scales. Temperature of vacuum is undefined. Absolute zero and triple point are standard fixed temperature. Is modern thermometer. Priometer is high temperature. Cryogenesis is called low temperature. Thermoequilibrium. Thermoequilibrium is the state of liquid equality. Equality means having equal number of temperature in all spaces. It's called state of liquidity equality or in temperature is called thermoequilibrium. Net transfer of heat is zero. Net change of heat is zero. All bodies have same final temperature is called thermoequilibrium. So heat and temperature. Zeroth law of dynamics. It is a fundamental law in thermodynamics which gives the idea of measurement of temperature. Okay, zeroth law of thermodynamics. It is a fundamental law of thermodynamics, which which gives the idea of thermodynamics of of the temperature of the temperature. It states that if a two temperatures are separately thermal equilibrium with the third system, when they must be in thermal equilibrium with each other. Proof: they also consider three thermodynamic system, i.e. A, B, and C, having final temperature T1, T2, T3 respectively. Since A and B are separated by with C by conducting walls, so they are thermal equilibrium, i.e. T1 is equals to T3, T2 is equals to T1 is equals to T3, T2 is equals to T2 is equals to T3. From the equation I and II, we can say that T1 is equals to T2, which means it is the perfect example or a perfect proven diagram that the both A and B are in thermal equivalence, even though they have an insulating wall between them. Significance. According to the zeroth law, temperature is measurable property which decides whether the systems are in equilibrium or not. According to the zeroth law, zeroth law, temperature is measurable property which decides whether systems are in whether their systems are in equilibrium or not. Whether the systems are in equilibrium or not. Significance. According to the zeroth law, the temperature is measurable property which decides whether the systems are in equilibrium or not. Thermometerity, meteority, met, thermometry. Okay, it is a branch of physics that deals with this construction that deals with the study and the measurement of the temperature is called thermometry. The branch of physics that deals with the study and the measurement of the temperature is called thermometry. A device used to measure the temperature is called thermometry. Essential requirement to prepare the thermometer. There are three essential requirements to prepare thermometer. They are construction, calibration, and sensitivity. Construction is the proper choice of working substances is called calibration. It is called construction. The proper choice of using substances and working substances is called construction. The proper choice of means कुनै पनि thermometer बनाउनलाई proper substance को choice लिनुलाई नै construction भनिन्छ. For construction, there are proper choice of working substances such as whose measurable physical property may vary with the change in the temperature, which varies in the change of the temperature. Calibration. Calibration is a process of providing scale for a newly constructed thermometer. For example, for a calibration, there is 2 points: upper fixed point and a lower fixed point. Uh, the process of providing scale for a newly constructed thermometer is called calibration. For example, to provide calibration, we need to provide a newly constructed thermometer with upper fixed point and a lower fixed point. Lower fixed point is where the pure ice just melt under the standard atmospheric pressure, and upper fixed point is at the temperature where the pure water boils at the standard atmospheric pressure. Sensitiveness, it defines as the ratio of the change of a physical compound property of a per unit change in the temperature. The temperature is said to be more sensitive if it measures small range of temperature, measure thermometer in a small interval of a time. So centimeter can be said as that said as that if the thermometer measure in the small range temperature, it measure in the short interval of time, it is called the sensitivity of the thermometer. It is defined as the ratio of change in the physical property of a per unit or a per unit change in temperature is called the sensitivity of an thermometer. Note: sensitivity can be increased by making the largest possible surface area of a bulb of the thermometer, using narrower capillary bore, using thinner wall of bulb of thermometer, changing working substances of high uniform coefficient of the thermal expansion, different temperature scales. They are different temperature scales. They are Celsius scales, Fahrenheit scale, Fahrenheit scales, Kelvin scale, etc. And Newman scale, Rankine scale, etc. So we have seen that. Okay, okay. At what temperature does the Kelvin scale collide with the Fahrenheit scale? At what temperature the Kelvin scale coincide with the Fahrenheit scale? Okay, let's Google about this. Okay, I don't know about this. So let's solve this. Okay, so at what temperature does the Kelvin collide? Yeah, hmm, there you go. So the answer is showing that at 574.5 degrees Celsius, meaning the 570 can be equals to the 574.59 degree Fahrenheit. Why? Whoa, 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 whoa. So let me write this answer for right now. At 579.59 Fahrenheit or Kelvin, 579.59 dot no, Kelvin does not contain degree Celsius. Okay, it does not contain degree. So as you know, we have found another good thing. Mm, I think probably this numerical will come in the MCQ, which it shows that the change between the temperature and the Celsius scale. Okay, for that I have the calculator which directly shows the change between the scales, but it does not show the Kelvin scale. But Kelvin scale is just simple. If you got like 73 degrees Celsius, you can just plus 273. You will get answer. Let me guess. 273 plus 73 degrees Celsius is called 346 Kelvin. So we can just do that and find the Kelvin scale. And we can. Let me wait. I think there is to find the mm, which they have volume pressure energy one. So yeah, we can find it. So we can find it for right now. I will be blocking audio for a while. Don't take tension. I will be starting for right now. Just give me a sec, okay? Okay, solution C is equals to 37 degrees Celsius, F is equals to 100 degrees Celsius, Fahrenheit. Error is equals to delta C is equals to a question mark. We know that C minus 0 by 5 and is equals to F minus 32 by 9. C change by 5 and 100 degree minus 32 by 9. C delta is 37.77 degrees Celsius, or error in delta C is 37.77 minus 37 degrees Celsius is 0.7. Okay. So there is a lot of numerical over here. The questions, okay, the distance between upper fixed point and the lower fixed point is at the CL. Find the temperature on the Celsius scale if mercury level rises the height of the 10.5 cm or above the LTV, means lower fixed point. Okay, so solution, okay, x2 minus x1, x2 minus x2 minus x1, okay, and 80 x3 minus x1, x minus x2 x3. Solution here for G scale, r prime is equals to G, U is equals to question mark. For Celsius scale, R is equals to C is equals to 62 degrees Celsius, L1 is equals to 40 degrees Celsius, and U prime is equals to 209 degrees Celsius. For Celsius scale, L is equals to 0 degrees Celsius, U is equals to 100 degrees Celsius. Mm, Okay, thermal expansion. The tendency of an increase in the shape and size of a dimension of an object is called thermal expansion. Causes of thermal expansion. Each atom of the matter vibrates about their mean position. When the temperature increases, the kinetic energy and the vibration of an atom also increase. Due to this, average distance between the atom also increases, which leads to the increase in the dimension, which is called the thermal expansion. Expansion of solid. Since the solid has a fixed shape and the size, also it constitutes all three types of thermal expansion. They are linear thermal expansion, superficial thermal expansion, and cubical thermal expansion. Okay, for the definition of the quantity expansion was linear thermal expansion is that the increase of the length of an object due to the change in the thermometer temperature is called linear linear thermal expansion. The increase in the length of an object due to the change in the thermometer is called linear thermal expansion. It is called one linear one linear thermal expansion. One linear thermal expansion. Ah, okay, wait, guys, wait, guys. Just wanna do something real quick. Wait, guys, wait. So, let's see. So that and let's start. At the end of the day, we can say that L square L2 is equals to L1 L1 into 1 plus alpha delta alpha delta alpha alpha delta beta. What does it mean? But it is the formula. And L2 is always greater than L1. It is constant. constant. New time dimension. We know that alpha is equals to delta L and by L1 delta B delta beta, and alpha is equals to M by M into K, or alpha is equals to 1 by K, or alpha is equals to K minus 1. Unit of delta is K minus 1, or 0 degrees Celsius K minus 1. The value of alpha is always plus positive. The value of alpha is small, and alpha is equals to 10 to the power minus 5 is equals to 10 to the power minus 6 K minus 1. The value of alpha remains same for a wide range of temperature. The value of alpha lies between 0 to infinity. Does the value of infinity depends upon the original length? Explain. No, it doesn't depends upon the original length. It values depends upon the natural solid. Does the value depends upon the original length? No, the value does not depend on the original length. It depends on the value that depends on the nature of the solid. Mathematically, delta L is by L1 delta beta. For every degree rise in the temperature, ratio is delta L by L1 remains constant. Superficial thermal expansion. The tendency of an increase in the area due to the change in the thermometer, change in the temperature is called superficial thermal expansion. It is also called 2D thermal expansion. It's called 2D thermal expansion. The tendency of an increase in the area due to the change in the temperature is called superficial thermal expansion. It is also called 2D thermal expansion. It's called 2D thermal expansion. In year two, we can see that L1 and L2 in L1 and L2 is always greater than the L1. It is all like all concept, all the derivation we can see over here. Relation between alpha and beta. Let us consider a metallical cube of initial depth L1 and an initial volume V1 at the Q1 when the metal's cube is heated at Q2 degrees Celsius, when the temperature cube is heated at Q2 degrees Celsius. Q2 degrees Celsius. So, um, okay guys. Okay guys, wait. What about this? Yeah. So I'm back. So let's start studying. I need my mobile for a sec. So don't worry. I'll be with you. Okay. Sit over here, guys. Don't panic, okay? Don't panic. I'll be here. Just wanna make sure something is incorrect or not. There is already 7:20 p.m. over here. By the way, guys, the exam is gonna be over tomorrow. Means it's gonna be on Monday. Today is Saturday, and tomorrow is Sunday. I'm bit of scared right now. So I'm back. I'm back. So yeah. Wait, sir. Wait. Wait. Yeah, wait. I'm back. So start my video now. So click on over here. Not in my phone. So yeah. Most of the time, in fact, mostly my like camera problem. Nothing else. I will not be doing anything else. My phone. Yep. So I'm back. Consider a relationship between alpha and beta ring. Let us consider that the metallic cube of the initial length of L1 initial volume V1 at the Q1 when the metallic tube is heated at Q2 degrees Celsius and Q1 degrees Celsius when the metallic cube is heated at Q2 degrees Celsius. So that's final length and volume becomes H2 L2 as shown in the figure. Form the form the figure. V1 is equals to L1 cube and V2 is equals to L2 cube. V2 is equals to L1 L plus B degree cells alpha degree beta and V2 is equals to V1 1 plus gamma delta beta means expansion alpha gamma means cubical expansion from the V1 and V2. Okay, so L3 cube V1 V1, so we can call it V1. After calling V1, we will show that COV. So means alpha means gamma is equal to 3 alpha means 1 cubical expansion is equals to 3 linear expansion. Then see between alpha, beta, and gamma 1 to 2 to 3 or ratio. If so the copper wire of a length C increases with the length by 1%. Find the percentage in the change in the area of the same copper wire from the dimension L into 2L when heated from temperature Q1 degree Celsius to Q2 degree Celsius. Given percentage change is theta L into 100 degrees Celsius is equal to 1 Initial dimension of the object is L into 2L. Initial volume is equal to L into 2L is equal to 2L square. Now, uh, L1 is equals to L plus theta L plus by L plus 2 theta L to beta L. So we can do this. This means change in area is 4L theta L. Percentage in cell is 2 theta L 2 by theta L by L. 200% percentage is just 2 into 1 is 2%. You can directly like change in like we can just say that it is 2%. So dimension linear expansivity of the solid in Pugliese apparatus. It is based on the principle of the thermal expansion in the solid expand on heating. Experimental setup: galvanometer and spirometer and central leg galvanometer, battery, etc. Experimental setup. You all know. I think it doesn't. It won't be coming in the exam about this. So let me see. Okay, let me see. So is gonna see is that heat temperature and heat temperature, heat and thermal expansion, stress and strain, stress and strain, and thermal stress, thermal strain. Okay, thermal stress and tension due to the temperature, change in temperature. Okay, so probably I expect that strain and stress is probably about this. The strain and stress. Yep, yep, yep. So up to now, so I need to do some numerical. So yep, let's do some numerical. I will be back there. You can see my head if possible. So, yep, you can see my head. I will be doing my numerical stuff. Now, there we go. And by the way, chat, if you guys interested, I will be doing 1 hour streaming, 1 hour stream before I will go, when I will go for my exam, to give my exam. So if you are guys interested on that, please follow. Okay, please follow. By the way, even though my exam is starting in 7 o'clock, I should be in college in like 6:30 p.m. p.m. and and I think I need to move from here at like 5:45, like 5:45, like 6 o'clock. I gotta move much earlier in morning because it's morning. Yeah. For actually, it's gonna be like for 3 days, so no more. Yep. Up to now, we have got three views, okay, and no zero not correct viewing. So nobody is watching me right now, but we have got three views. There you go. We got three views. There. It's gonna be liquid, common and liquid expansion. Individual common expansion. Normal core temperature in the body is at 24 degrees Celsius. So it's gonna be conversion of scales between the scales. Okay. Let's see from here. 29. 29. 29. Okay. 29. It's gonna be lot of numerical practices. So yeah. I hormone expansion. And as well liquidity expansion. I think liquid expansion has been not being taught to me up to right now. It's gonna be like about solid expansion quantity now. So up to here. So yeah. So let's do like basic conversion between scales and mm, uh, guys. Right now, give me a time break right now. It's gonna be I'm just gonna hit 1 hour thing. I'll be doing I will be finding my let me say I'll be finding um my my profile. So yeah, I'll back in one like 10 to 15 minutes. So guys, I'm back. I'm back. So yeah, sorry for that, and I'm back. Hey guys. Charles will be first, and then calling down. What do you mean by that? To start the question, what do you do? What will you give for my negative charge to a conductor by the method of induction? Repulsion is the surest test of electrification rate. Vector number, all vectors, triangular and parallelogram vectors will come, and conversion between the system and logical questions. The logical to the optical quantities having them justified and mm, and these zoologist questions we are talking about the MCQ one. Um, I'm a bit scared for the exam for a second because I have learned nothing. Like what? My exam like must be good. Always giving my exam worth it and expecting so yeah. Actually most of the time I will be like watching videos and running. But when I stream I just do studying and do nothing. So that's the proof of my game streaming. Um, yeah, convert 100 is 100K into Kelvin on the Fahrenheit scale. Okay, you can convert solution to here, solution here. What we can say? One L2. Oh, it is over here. Wait. I think it is shown in my this copy. In this copy that it has shown the conversion between these scales, like Fahrenheit scale, Celsius scale. So we can learn from there. So first of all, we have given the Kelvin. Okay, so directly we will convert into Celsius scale, and after getting in the Celsius scale, we can use the formula which is 9 by 10 to the power 90, the Kelvin scale. Yeah, basically, we can just use that formula. Oh my, what? It is also important by the way. Mhm. So just don't waste our time and temperature scale. mm, Temperature scale in what? At Kelvin scale. 100 and temperature scale in Celsius scale. Tc is equals to degree Celsius. So since we have the relation Tf is equals to 9 by 5 Tc plus 32, or no, not for this. We can directly, since we know, or we can say that Kelvin is equal to 273 degrees Celsius by 100 is equals to F minus 32 by 180 degrees Celsius, or So we can put the value of k, which is 100 and 100 and 293 degrees Celsius by 100, and f by 32 by 100. So we 100. So degrees Celsius into 100. Yeah. Then after my f 32 into 100 or 100. Use my calculator. Guys. Minus 273 degrees Celsius. So that would be minus 273 degrees Celsius into 100. You can say that 173 into 0 and 100 and minus 30 to 100 or minus 173 into plus 32 100 equals to 100 and what you can just 173 plus 32 100 equals to 20 14.100 by 100 is equals to f. F is equals to 145 degree Fahrenheit. That would be answer. Yep, that would be the answer. Okay. 173. 200 is 2 minus 273 9 degrees Celsius. Why? So is this something wrong? Wrong formula again. Wrong formula, right? A minus 273 by 5 is f minus 42 by 9 or 100 minus 273 by 100 is equals to f minus 273 divided by 9 or 100 minus 173 degrees Celsius into 9 into 9 by 100 by f minus 32 or 179 into 9 is minus 15.7, or we can just say that 5 plus 15 7 7 plus 32 16 43 1643 by 100 is 16 degree point 43 degrees Celsius. Yeah. Oh my god, this is so important, man. This is so important. Okay. So solution here, K is minus 273 Celsius by 5 and F is minus 32 degrees Celsius by 9. Or we can just cross multiply them is 273 degrees Celsius x minus yep. Let k is equals to 5 is equals to x. So x is equals to x minus 32 by 9 by 5, or x is minus 273 degrees Celsius into 9 is equals to 5 into x minus 32, or 9x minus 273 into 9 is 247 is equals to 5x 5 into 32. 32 is 160. 90x minus 5x minus 160 plus 257, or 99 4x is equals to minus 160 plus 247 is 297, or x is 2297 divided by 5 is equals to x is equals to 573. 2297, so 425. There you go. Kelvin. So now, in what temperature the Kelvin scale is double of the Fahrenheit reading? It's double the Fahrenheit reading. At what temperature? Mm-mm-mm. So, in that perspective, we can say that solution here, let k is equals to f is equals to k is minus 273 degrees Celsius by 5, and no, 2x, and f is x by 5 is equals to x minus 2x minus 273 degrees Celsius by into 9, or 5x minus 242, or 9 is 18x. One 60 plus 2 plus 97 by 3 is 7 6 5 6 6 7 6 7 7. Is that true? No. In what scale? What scale? So 7 so 765.667 divided by 2, 282. No, something is wrong. A body thermometer has fixed point at -2 and 28 degrees Celsius. What is the correct temperature on Celsius when the temperature reading is 20 degrees Fahrenheit, and answer is 22. Okay. So In some cases, you can most of the time it will ask that at what point the Fahrenheit scale is equal to the Fahrenheit scale, at what point the Kelvin scale is equal to the Fahrenheit scale, or it just asks that what is the value of Celsius of like 32 degrees Celsius. We can just assume that for right now. So solution here, the probability method would be like this. Okay, solution here for correct thermometer, upper fixed point. For this, all questions will not be asking in exam. No. U1 is equals to 998 degrees Celsius and lower fixed point. If this question comes on MCQ, just you can just predict it's like 2 degrees Celsius difference, and you just go for it. R is equals to C is equals to 20 degrees Celsius. Now applying formula R R1 yeah, R1 is R minus CL and U minus C and R minus R1 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 L1 is equal to U as C1 degree Celsius, 100 degrees Celsius minus 0 degrees Celsius. 98 2 by minus 2 2. Oh, wait. Quite funny. There is another type of question now. Wait. At the pole of temperature at the Fahrenheit thermometer register at All questions have been done by my professor already. I think in the exam point of view, it is like in the point in the exam point of view, it is more important. Solution here. So that one. So this is x1. This is x2, and this is so 10.4, and this whole is for ATCM, and this is like Q1 degree Celsius. This is Q2 degree Celsius, and this would be like this would be the Q3. Hmm. ITP, UTP, you can just say that. LTP and UTP. LTP, LTP are C Celsius, and UTP is 100 degrees Celsius, is 0 degrees Celsius, and now we can say that C or R is R minus L, U minus L is equals to x2 minus 1 x1, x3 minus x1, or C minus L, U minus L is equals to 10 to the power 10.80, or C minus 0, 100 degree minus 0, or 10 to the power point, which is 80, is 13 degrees Celsius. I hope this is the only one. 140. 140 divided by 80. That's 30. Yeah. So for heat and temperature, the question has been done. Oh, there's a good one option. So 40 thermometer shows 140 Fahrenheit, whereas the centigrade thermometer, which is means Celsius thermometer, shows 95 degrees Celsius. Okay, find the correction 40 thermometer has. So first of all, we need to convert TF. Okay, TF into like TF into TC. So we can just do that by shift by 8, temperature 1, and 204 is equals to 95, 95.0 is already 40 for right now. This is 203. So we can just normally convert TC into TF, and we can say that there is a difference is quantity Celsius 1 Fahrenheit. Oh, we cannot say that. So solution here 40 thermometer reading, water thermometer reading in F is 240 degrees Celsius, and or we can just say Fahrenheit. Fahrenheit, and correct thermometer reading in 6 degrees Celsius is 95 degrees Fahrenheit. Correct thermometer reading in degree Celsius in Fahrenheit is in degree Fahrenheit degree Fahrenheit is 203 Fahrenheit degree Fahrenheit. So now error one measure or correction is equals to correction is equals to is 104 minus 103 is equal to 1 degree Fahrenheit. So we can find like that. The thermometer reads 270 degrees Celsius when the standard Fahrenheit thermometer reads 100 degrees Celsius. What is the error in the error? So for this question, we can assume that. So basically, I'm not having all the like 80 37.7 degrees Celsius. Like we can find out that. Okay. Now thermal expansion. Copper length of a 7 mm is heated from 30 degrees Celsius to 80 degrees Celsius. If its length increases by 2.55 meters and calculate the coefficient in a copper expansion, what is the temperature? Hmm, okay, this is new. The solver hole of a radius 1 cm of a brass kept in the 293 Fahrenheit. What will be the diameter of hole when the temperature of CFE is increased by 100 Fahrenheit? Okay. But in this question, it is given not given the expansivity of the like copper or like that. So L2 that is the length of expansivity coefficient of the expansivity. This is like the topmost position now. So guys, I'm gonna take for a break for a while. I'll be back after eating a lunch or something like that, like dinner, and it's already been a long time. Let me see the time and so congrats all for being over here. We have just hit 1 hour streaming and thank you so much for that. Thank you so much for that. Thank you. And I'll be back in like 5 to 10 minutes. You guys got some updates. Okay, updates. So sorry to disappoint, and we have hit 2 hours of streaming, but sorry to disappoint for right now. Um, mm, the problem that we are currently facing is our showing right now. Like 2 days ago, the cold calling services which I told you about just right now was working, but right now it's showing this problem. Just hear it. Okay. Again, it's showing the problem of technical problem. I don't know what to do right now. It's again showing the problem, and there's there's no way that now I can solve this because it's been like third time that we like that I have report to the support team about the same problem. Mhm. And yeah, I should be in a meeting in a second, so I need to go for right now. Sorry guys to disappoint. So I'll be in the streaming in like in next 1 minute or like ending right now. Thanks for so much for watching. And yeah, I got 10 views and one current viewer. Thank you so much for watching. It was amazing talking to you all. And the Jack Tony 911, thank you so much for being stream, and thank you for commenting. I know who are you, and yes, thank you so much, bro. And thank you so much for watching, and goodbye. And I will see you in tomorrow hour of 12-hour stream. I want to announce that tomorrow I will be streaming for 12 hours. So as you guys know that YouTube do not let us like stream for like 12 hours straight. It will like cut off my stream like stream in when I pass like 11 and 30 minutes later. It will, like YouTube will cut off my stream. So yeah. Okay, so yeah, bye bye, see you guys tomorrow. And those who are guys are walking okay watching me right now, thank you so much for watching, and see you tomorrow. Bye bye. And yeah, peace. I need to be in meeting. Okay, I need to be in meeting. So thanks so much, and peace guys.